Hello and welcome to SPSS 3 from part S28. So we're going to do the other error bars for other variables now. So what we'll do is go to here and just save this one, because we imported this from Excel. So if we now save it, this is the data on birds. So it takes a few minutes to come this to come up, and I'm going to save it as birds, and it's birds 1 as well, just 2 on birds. And this already exists, so yes, I'll replace it because I've already done this, obviously. So save that. Once you've saved it, what we could do then is we could just import the data from Excel, but then you have to do all that tidying up stuff again. So it's actually slightly simpler, instead of that, just to cheat and go to Excel and just go to arthropods, which is spiders, the next one we want to do, and just cheat by selecting all the data. You can only do this if the setup is exactly the same, all the same variables, the same formats, same number of observations. You could change slightly, but it's 43 again. So go to that, copy that, go to SPSS, click on the top left corner and press Ctrl V. Okay, you can see it's copied it in, numbers match up. Took a bit longer than I expected. Once you've done it, then save that as something. Okay, my computer's quite slow. I'll call this arthropod. That's how you spell it. .sav. Then we can make the error bar for that as well. In fact, it's because the setup is exactly the same again, so you don't have to change anything. Same variables, it's just the data has changed. That's the output. We bring up. Hopefully, this is still enough. That's this one, I think. Arthropods. See how that compares. It's again a similar pattern. So in this one, it's the selective. Where that cell red imp is. Oh, selective reduced impact is the best for the spiders. They actually like that, and some of these are not so bad. But on the whole, for the spiders, don't get carried away, because even the best one is only increasing the spider numbers by about 1.15%, 1.5 times. These are not making much difference, and all of these other ones are bad for the spiders, including the two that were the top performers last time. And this one particularly brings down the spider numbers. So even though it's good for birds, not for the creepy crawlies. But broadly speaking, our analysis has given similar results to these, including the spreads as well. So the ones with the wider confidence intervals, we've also got wide confidence intervals in ours. Okay, and as you learn a bit more about confidence intervals, you might get a clue of why that is. Okay, so now that's the data. We now need to move on and look at the plant data and also the second sample of bird data. So just check we've saved that as spiders. We have. So now we can do the same trick again. I'm just going back to forest. Goes to the plant data. Copy all of that. SPSS. Paste it in again. Check it's changed to match it has. Yeah. Save this as plants. Do the same thing again. No need to change anything because it's the same variables. Here's the output. So there's the graph for plants. Let's compare that with the one in the original article, which is plants. Yeah, again, similar pattern. So here, again, not brilliant because there's only one. So selection is the best performer again. They're bad for spiders, but good for birds, good for plants. But increasing it by 1.1, so 10% increase, whereas all these others are worse. Particularly these ones, again, were really bad in the first results and really bad in the second set of results. So all these management systems are really quite disastrous for birds. Like this is like 0.5 would mean half the biodiversity. So these ones that are down here are like below half the biodiversity, with things like slash and burn, not surprisingly, non-fuel plantations. So these are the bad ones for plants. But similar kind of pattern in our data to the one in the article. Okay, so back to SPSS, we've saved that, so we can then grab the last one from here, which is birds 2. So there's 2 samples of birds data. How do we manage that? But we can compare the results if the 2 samples are telling us the same things about birds. Go back to there, paste it in again. So it's changed and save it as birds 2. Same graph. Who's made the birds one? It's got employment category. So mislabeled. This should say management category. That's not confusing. And this is birds against means compare this back with birds. Yeah, so it's telling a similar story. Again, because it's another sample of birds, and hopefully this last one should be telling a similar story to our first one, which is where our paper was at. Again, it is. Great. However, so the error bars all seem to match up and they're compatible with each other. But if we go to here and we do, instead of error bars, for the second bird sample we do another thing we started, which is just the plain bar chart. I think we'll have to start again. Now we've got another bar chart based on birds, which is this one. And at first glance, this looks kind of pretty much the same story as the original bar chart. But if we answer the original questions again, which is question 4 was saying, okay, on average, which forest management system is best for birds? So first sample of birds is that, almost doubles it, great, so that's the best. And also here, not quite as good, but definitely the best. So selection seems to be the best in both the samples. Okay, which is best out of these two, retention or selection? Well, here it looks like retention is a bit better than selection. Sorry, selective reduced impact. Retention is better than that. In the original sample, retention was slightly worse than selective reduced impact. So in this sample is telling us that retention is not quite as good as that one. In the last one, in the other sample, again of birds, it's better. And the other comparison was between fuel and slash and burn. In this sample here, the second one's plain fuel is worse than slash and burn. Whereas I think in the original one, the same story. No, plain fuel was better. So again, it's reversed. So the 2 samples are giving us the same message that selection's the best, but they're flipping the order between these 2, retention, selective reduced impacts, and between fuel and slash and burn. So some of the other messages about which one's better and worse differ between the 2 samples. This one doesn't differ, the selection's still the best. So this poses a really difficult problem for us, which is that when you do some research, usually you just get one sample, you're looking at this. How do you know which of these messages are telling you the true story about the comparisons? Like if I went and did another sample, how do I know it wouldn't flip round? If I did the comparison instead using these, however, the confidence intervals, and this is now as a question, oops. This is question 8. You get it's slightly easier. And the reason is, I can see it selected as better than the others. You see that the point of the confidence interval is that the confidence interval in a sense, it's less precise than the bar chart, but the bar chart is giving you false precision because the bar chart is telling you that is the number for selection. Whereas in fact we know that there's a bit of a range. The error bar is saying, okay, we know that that's the number I got in my sample, but based on that, probably the real answer is somewhere in here somewhere. So the real mean in all the areas that have this selection system is somewhere in there. And because this does not overlap with any of the others, we can be fairly confident that wherever this one really is and wherever these ones really are, they aren't the same. So we're fairly confident that selection is definitely better than the others. Whereas a lot of these other ones overlap. So for example, these two I was comparing, there's massive overlap. So it could be that the true answer of both of those is 1, but they have no effect at all. Yeah. So, or anywhere in that range. So because they both overlap, it's not surprising if you take any sample, because sometimes one's ahead, sometimes the other's ahead. These samples aren't telling us which one is better than the other, because it could be they're both the same. And the same with these two here. Massive overlaps there. And in the other error bar one, you'll probably find the same thing again. Yeah. This one doesn't overlap, so that is higher than the others. These two massive overlaps, so they aren't higher. These two massive overlaps, so they aren't higher. I mean, sometimes you can tell between these two. This group here doesn't really overlap with this group here, so this group seems to be better than this group. There's hardly any overlap in either of them. And so, yeah, this group here kind of ahead of all the others, apart from possibly that one. So you can pick some differences in the others where the error bars don't overlap. And then you can look at the other ones we've done between for things like the impact on spiders, I think it was. This is definitely better than this, for example. But this and this, they could be the same. So with error bars, you're looking for things that don't overlap. You can be fairly confident those categories are different. If there's quite a big overlap, then it's not really telling you anything. They could be the same. So if you look at arthropods, again, that's what I just answered. In arthropods, you can be fairly confident that that's the one that agroforestry is better than plain non-timber, and selective reduced impact is better than these ones here and these ones here. But selective reduced impact and agroforestry, you can't tell the difference. Okay, so that's the answer to question 9. The ones that don't overlap, the ones that you can be confident are better or worse. Okay, it's probably not worth doing another video for these, but let me just comment that, well, I don't think I need to go through these two things. The same is true for plants and for the plants one. These ones here clearly don't overlap with any of these ones down here, but they do overlap with this one. So these seem to be better than all of these. This one's the worst. Well, no, this group here, all the worst, they all overlap. This one seems clearly better because it doesn't really overlap with those there, so clear cut's better than these other alternatives for plants. But these are better than all these down here. And similarly here, this one's, that's better birds again. So question 10, you can see, as for the other questions, the ones that don't overlap are the ones that are definitely better. Just note that because of this limitation of bar charts, it is possible, when you make a bar chart, that's really, really simple. So I deliberately didn't show you this at the time, but when you make a bar chart like this, there's a box somewhere just display the error bars. Yeah. So this time when you do it, you get the bar chart with the error bars added. So you can tell this one's bigger than that because they don't overlap. Some people like to have the bar chart with the error bars on it. Other people like to have the error bars themselves. I just got used to the error bars on their own because this article, and it's quite common these days just to do just the error bars because what do the bars add? So lots of articles just use error bars like these. So it's up to you, but I'd certainly suggest either do just the error bars, or if you do a bar chart, always put the error bars on it. And so to answer the final question, I recommend that if you're doing the bars when each height of the bar represents the mean of a value, then always put the error bars on, because otherwise, when you look at something like this, you can't tell whether that's enough to tell you that this category is really bigger than that one. When you look at this, you can tell that the error bars massively overlap, so that difference doesn't mean anything. Could be if I do another sample tomorrow, it'll be the other way around. Yeah, the same. But I could be fairly confident this one and here there is a difference because those things don't overlap. So if I did another sample, probably I'm always going to find this one's bigger than this one. So I recommend it because it lets the reader also judge for themselves which of these things are reliably going to be higher or lower, and which it could just be the luck of the day when I did this particular sample. So please use confidence intervals, use error bars. They're tremendously useful to the reader, very easy to do. So what's not to like? Okay, so that brings us to the end of this session and question 11. And any questions, please do get in touch, forums, and in the live classes. But for now, thank you for watching.